Good afternoon. Today we are going to solve a worksheet related to chapter number 1, information representation. The first question is that you have to convert a denary number 374 into a hexadecimal number. So always remember then when you are asked to convert into a hexadecimal number. So hexa has a base of 16. Why? Because it has total 16 digits that are starting from 0 till 15. Okay. So from 0 till 9 we have regular number 1, 0, 1, 2 till 9, and from 10 to 15 we have the equivalent code for that. For A we have 10, for B we have 11, and so on up till 15, right? Now, so how do we convert 374? So whatever number you are being given, you have to convert it by dividing it with the 16. Why? Because our base of hexadecimal was 16, right? So I'm going to divide it. So 16 times, so you should also have a good math for that. So how many times we will do multiplication with 16 so that we get the nearest digit to the 374. So I will do 16 times 23, okay, and I will get the remainder of 6. Okay, then again I will divide it. So 16 times 1 is 16. So if I do 16 times 2, it will be 32. So which is greater than 23. So I will do 16 times 1 is 16 and the remainder is 7. Okay, so my answer is for this question 1, 7 and 6, and I will write it in brackets and I will write here 16. Why this 16? It is representing the hexadecimal number. Okay, now let's solve the part number B. In part B, you have to convert the hexadecimal number into the denary number. Okay, so this is the opposite question of part A, right? So what is the number? 3A 2C. So now I have written this number over here. What I have to do? Simple, very simple. Just remember some rules. 3 multiply by 16. You have to multiply each digit with 16. Why? Because this is a hexadecimal number, and then keep on adding with the next digit. Okay, now here you will see A. Okay, so I just told you in the start of the lesson that for A till E we have equivalent code. For A we have code 10. Okay, and then you have to multiply it with again 16, then plus, right? Then 2, take this digit 2, then again multiply by 16, then plus, and the equivalent value for C will be, if it is 10, then C will be 12. Okay, so 12 multiplied by 16, right? This is step number 1. In step number 2, what you have to do, you have to start giving the powers in this direction. Okay, starting from this 16. So what power you have to give? You have to give 16 power 0 over here, 16 power 1, 16 power 2, and 16 power 3. Okay, this is not 16 multiplied by 3. This is 16 power 3, means 16 multiplied by 16 multiplied by 16. Okay, so whatever the answer will be, you have to multiply it with the 3. Okay, so I hope you can do this calculation. So once you are done, please check your answer. It should be equivalent to 1, 4, 8, 9, 9 and 2. Okay, that's it. Okay, and you can also write, if you wish, you can write like this 10. Why? Because this is representing a denary number, right? Okay, next question. Next question is, what is the weight of 6 in 65A hexadecimal number? Okay, 65A. Okay, let's write. The C part is 6, 5, and A. So they're asking for the weight of this number. Okay, so as we know, in hexadecimal number, what we do, we have to multiply each number with 16. Okay, so if this weight is 16 raised to power 0, starting from this direction, 16 power 0, it is 16 power 1, and this is 16 power 2, right? So what is the weight for 6? The weight for 6 is 2. Okay. And if they've asked you the value, so what you will do? You have to, yeah, you have to multiply 16 multiply with 16 and then multiply it with 6. So what are the answer? That will be the final value for 6 for this digit, right? Okay. Okay, next question is, part D is convert the binary number. This is the binary number they have given to a hexadecimal number. 110. Okay, let's write it over here. Okay, this is the number, okay? 11001011, right? So what we have to do, we are supposed to convert this binary number to a hexadecimal number. Now remember, whenever you are given this type of question, like let me rewrite 11001011. Okay, so let's count the number of bits in this whole byte. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 bits, right? So you are supposed to convert in hexadecimal number. So what you will do, you will make a group of 4, starting from your right side toward the left side. Okay, so in this way, I got 2 groups, right? After making the groups, you have to assign them the power of 2, right? So what is the power of 2 here? It is always 2 raised to power 0 is 1. So I will give the equivalent value over here. 2 raised to power. Okay, so I will change the color. Okay, 2 raised to power 0 is 1. So here 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, and 2 raised to power 3 is 8. Okay, so just memorize this sequence. Okay, so when you have to give the powers from your right to left and you are dividing into group of 4, so what you can do, you always have to give these 4 powers 1 2 4 8, and similarly again repeat for the next group 1 2 4 and 8. Okay, so now what you have to do, uh, you only take the bits that has the value of 1 over here and just add them. So I'm just cutting them so that I don't add them in my final answer. So what I have to add, I have to add this power. 8 plus 4 is 12. Okay, and this 8 plus 2 plus 1, 10 and 11. Okay, so as we have to write the answer, we have to convert it into hexadecimal. So when the digits are greater than 9, we don't write like this 12, 11 or 10. We have to write their equivalent value. Okay, so I told you for hexadecimal, let me rewrite the value. For A, it is 10. For B, it is 11. For C, it is 12. D, it is 13. E, it is 14. And for F, it is 15, right? So according to this table, what is the value of 12? We can represent 12 with this C. Okay, and 11 is represented by B. Okay, so this is our final answer. So we can also write in like this. It has a base of 6, right? I hope it is clear. Okay, next proceed to the next question. Next question is, convert the binary number 1101111 to a denary number. What you have to do, binary to denary. Okay, the number is, let me write it over here. The E part is 11110 and 5. Okay, so this is a number and we have to convert into denary. So what you can do, again, when you're converting a binary number into denary number, the simplest way is that you can give the power. One is the long method and one is the shortest method. Okay, I will start from the shorter one. Okay, what you can do, start giving them a power of 2. 2 raised to power 0 is 1. 2 raised to power 1 is 2. 2 raised to power 2 is 4. So in this way, I will keep on increasing the power and I will write the answer over here. 1, 2, 4, and then it will be 8, then it will be 16, then this will be 32. Okay, 1, 2, 4 is 16, 32, and the next one will be 64, and again the next will be 128. So every time you have to increase the power of 2. So 64 times 2 is 128. Okay, so now what I will do, I will just cross out the value that is having 0. Okay, and then I will just add the values which are having 1 value. So I will be adding this 128 with 164, then 16, 8, 4, 2, and 1. Okay, so what you have to do, please write down in the comments what is the final answer by after adding them, right? So this is the method. Okay, the next question is, you have to convert the following numbers into the ones complement. So what is the rule for ones complement? If you have, I will solve the part number, suppose I'm going to start with part number 2. Part number 2 is, there are 4 ones and 4 zeros. Okay, so let me show you. This is question number 2. So I will take the part number 2 for this, and what is written over here? 1, 2, 3, 4, and double 0, double 0. So you have to convert into ones complement. For ones complement, simple. You have to, invert all the digits. If it is 0, you have to convert it to 1. If it is 1, you have to convert into 0. So simple, 1, 1, 1, 1. This will be 0, 0, 0, and 0, right? This is the conversion for ones complement. Okay, so let me show you the next part. So these are your homework, and please write in the comments what will be the answer for 1, 3, and 4 parts, right? Okay, now next one is, sorry, 1, 2, 3, and 4 for this part. Now next one is, you have to convert into 2's complement, right? So what is 2's complement? For 2's complement, first you have to write down the 1's complement, and then you have to add 1, okay, to its rightmost side, and then whatever answer you get is the 2's complement. Let me take the example of this one. Again, the same, for the one which we did for 1's complement, I'm taking the same number, okay, right? If I'm taking the same number, so this was my original number, so after 1's complement I got this. So what I told you, for 1's complement you just have to invert the number. Okay, for 2 complement, what you have to do, simply you have to inverse all the number, step number 1, and step number 2, you have to add 1 to its least significant digit, okay, over here under it. So 1 plus 1, so now you have to just don't consider this number, you have to add 1 to this one. Okay, so 1 plus 1 in binary we know is, the answer is 0 and the carry is 1 over here, right? So again, 1 plus 1 is the answer, or the sum is 0 and the carry will be 1. So similarly for all, it is 0 and 1. Again it is 0 and 1. Okay, so 1 plus 0 is 1, and for the rest we will write the same over here. Okay, so this is our 2's complement. Okay, this is our 2's complement. I hope this is clear. Okay, now the rest you have to do as a homework. Okay, next question is, convert these negative decimal value to negative binary using 2's complement, right? What are we given? What we have been given here? We have been given the negative value minus 122, and we have to use 2's complement to to convert them into their their, we have to write their binaries 2's complement value. Okay, so for this question, I would like you to recall your concept, so that you should know how many smallest value and how many largest value can be represented by using a specific number of bits. If you are being given that you have to represent 8 bits, any number using 8 bit, and you are supposed to represent 192. Okay, I'm talking about the positive number. Okay, 192. So if you convert this 192, okay, using 8 bit, please check if it is coming in this formula. For you have to check the range. Okay, so how do we check the range of any number? Suppose we have been given that, can we represent any number? Suppose I'm asking you to represent 124 using 8 bits. Okay, this is a positive number. okay, and can we represent this number using 8 bit? So simple. You should remember this formula. For positive number, you can use this formula 2 raised to power n minus 1 minus 1. Okay, so here we have 2 raised to power 8 minus 1 minus 1. 2 raised to power 8 minus 1 will be 2 raised to power 7, and 2 raised to power 7 is equivalent to 128, and minus 1 equals to 127. Okay, so 127 is, you can say, is the largest value that can be represented using 8 bit. So if you are being asked to write down the or represent 1024 using 8 bit, so this is not possible because the largest value that we can represent using 8 bit is 127. Okay, so you have to increase the number of bits. So you have to think of ninth bit, or can we represent using 1024 using 9 bit. So what will be 2 raised to power 9 over here, 9 minus 1 8, so it will be 256. 256 minus 1 will be 255. Again 1024 cannot be represented by using 9 bit. Okay, so just keep on adding the bits and check whether this particular number can be represented using 8 bit or 9 bit or 10 bit. Okay, so this will help you in answering a question like this. So now what we are being asked, that you have to represent minus 192, okay, using the 2's complement. Okay, remember we have given minus 192. Okay, so one thing what you can do, you can use two different methods. First is that I can just ignore this minus sign and I convert this 192, only 192, into its binary value, which is actually 1 1 and 1 2 3 4 5 and 6. Okay, so only if I'm representing 192, this will be equivalent to this binary value. So for representing minus 192, first I have to convert into its binary number, ignoring the minus sign. Then I will add, what I will do, I will convert it into its ones complement by inverting all the digits, right? And then what I will do, I will add plus 1 over here. Okay, so just, okay, you add here 1 plus 1. Okay, similarly this is, sum is 0, carry is 1, if this will continue, sum again 0, again 0, carry is 1, 1 and 1 and 0. Okay, so this is our 2's complement value of which number? Minus 192. Okay, now how many bits are there? 1 2 3 4 5 6 7 8. Okay, 8 bits. So if you remember the formula for finding out the smallest number that can be represented using 8 bit, it is minus 2 raised to power n minus 1 for negative value. For negative value we will use this formula, but for the positive value we will use this formula, 2 raised to power n minus 1 minus 1. Okay, so I have been given negative value, so let me first, on a side, I will figure out whether this minus 192 can be represented by using 8 bits or not, because I got this answer, so I can check whether this answer is correct or not. So what I will do, I will use this range formula. So this minus 2 is actually 8 minus 1 is equals to minus 7. So 2 raised to power 7 is 128. So the smallest number that can be represented using 8 bit is minus 128. So they are asking us to represent minus 192, and how many bits I have here? 8 bits. So this means this minus 192 cannot be represented using 8 bit. There is something wrong over here, because the smallest value I can represent is minus 128. So what I have to do? So I have to increase my number of bits, okay, on my left hand side. So what I can do? I can increase this by adding, the another bit on my left side. Okay, so this was 8 bit, so now I will make it 9th bit. Okay, I will add over 0 over here in the original bit. Okay, this will become 9th bit. Now I have converted this, this was my 1's complement, so it will become 1. Okay, and in 2's complement this one will come over here. Okay, now if I check by giving them powers of 2, I can recheck the answer whether I will get minus 192 or not. And remember the rule that when you are being asked to represent a negative number using 2's complement and you are giving the powers, the last digit, the most significant bit, will be having a power of negative. Okay, so this one is 1, 2, 4, 8, 16, 32, 64, 128, and this will be minus 256. Okay, if it is positive, we used to write 256, but this is a negative number, and negative number is basically represented by 1. So if it is 1, it is representing that this is a negative number, and if the most significant bit is 0, it is representing the positive number. Okay, so what powers I gave? 1, 2, 4, 8, 16, 32, and 64. Why I'm not writing other powers? Because they all have 0 value, so I don't need to add them. So if I solve this, minus 256 plus 64, so I will get minus 192. Okay, so the question was that you have to give the equivalent, binary value using 2's complement. So our equivalent binary value using 2's complement is this: 101 000000. Okay, I hope this is clear. Okay, now let's take another example.